The fastest way to make SecurityX harder than it needs to be is to turn every objective into a separate acronym flashcard. CASB, SASE, SURO, SASCAP, Sticks, Taxi, Stride, CVS, Yara, Zero Trust, Shared Responsibility, HE Lifecycle, Trust Boundary, Residual Risk. Yes, you need to know the terms. But SecurityX CAS-005 is not only testing whether you recognize them, it is testing whether you can use them inside a senior security decision. So in this video, we are going to build a practical method for studying SecurityX objective by objective without getting trapped in random memorization. Objective by objective study sounds simple. Open the exam outline. Read one bullet. Make a flashcard. Repeat until you have hundreds of cards. That works for some foundational exams because many questions are about identifying a control, matching a term, or selecting the most direct answer. SecurityX is different. The official positioning is advanced, security architects and senior security engineers designing, implementing, integrating, monitoring, responding, and applying governance and risk strategy across complex environments. That means an objective is not just a thing to define, it is a decision to practice. If the objective mentions a technology, ask where it fits. If it mentions a framework, ask what decision it supports. If it mentions monitoring, ask what evidence proved the control works. If it mentions cloud, ask where shared responsibility changes ownership. The goal is not to memorize one sentence per term. The goal is to build a mental model you can use in scenarios. Here's the study tool for this series. For each objective, create a SecurityX decision card, not a normal flashcard. A decision card. It has 6 sections. 1. The objective topic. 2. The enterprise decision. 3. The architecture boundary. 4. The implementation and automation path. 5. The telemetry, evidence, and validation. 6. The residual risk and ownership. This converts the objective from vocabulary into judgment. For example, if the topic is CASB, do not only write Cloud Access Security Broker, write the decision. Are we trying to discover shadow IT, enforce cloud access policy, inspect SaaS activity, control data movement, or support audit evidence? Then write the architecture boundary. Is the CASB operating through API integration, proxy mode, identity integration, endpoint agent, or a combination? Then write the operational proof. What alerts, logs, policy violations, and reports show that it is working? That is a SecurityX decision card. The first question is, what decision is the organization trying to make? This is where governance, risk, and compliance enter the study process. A topic is not important because it appears in an acronym list. It is important because it changes risk. Take vulnerability prioritization. The beginner question is, what is CVS? The SecurityX question is, which vulnerabilities should be remediated first when severity, exploitability, asset value, internet exposure, compensating controls, downtime, and business impact disagree? That is a decision. The same logic applies to encryption keys, zero trust, SIM tuning, container security, third-party risk, and policy documentation. Start by writing the enterprise decision in plain English. If you cannot explain the decision, you probably only memorized the term. The second question is, where does this control live? SecurityX is full of boundaries. Cloud provider versus customer, identity plane versus network perimeter, data layer versus application layer, build pipeline versus runtime, preventive control versus detective control, policy decision point versus policy enforcement point, production versus development versus test. Inside your decision card, draw a tiny architecture map. It does not need to be beautiful, it needs to show the boundary. For zero trust, map subject, device, application, data, policy decision point, and policy enforcement point. For cloud data security, map object storage, database, keys, identity, logging, and data classification. For SIM, map log sources, parsing, normalization, correlation, alert triage, retention, and investigation. SecurityX scenarios often become easier when you can see where the control belongs. The third question is, how would this be implemented and maintained? This is where security engineering comes in. A senior answer has to survive contact with operations. If the control depends on a manual checklist that nobody runs, the control is weak. If the control is deployed once and never validated, it drifts. If the automation can contain a system without analyst review, it may create business risk. So when you study an objective, ask how the control would be engineered. Would you use infrastructure as code? Would you use policy as code? Would a SOAR playbook enrich an alert, create a ticket, recommend containment, or actually perform containment? Would patching be automatic, staged, or manually approved for critical systems? Would evidence be collected automatically for compliance? Implementation details are where SecurityX moves beyond vocabulary. The fourth question is, how do you know it works? This is the operations question. Security controls do not matter just because they exist on a diagram. They matter when they reduce risk and when you can prove their state. For monitoring topics, ask what the SIEM needs to parse, correlate, retain, and alert on. For threat intelligence topics, ask how raw indicators become detection logic and how context prevents false positives. For vulnerability management, ask how scanner output becomes prioritized remediation. For governance topics, ask what evidence shows a policy is implemented, reviewed, communicated, and mapped to controls. For incident response topics, ask what the organization learns after containment and root cause analysis. Telemetry turns a design into a managed security program. Evidence turns a claim into something audit, leadership, and operations can rely on. Here's an original practice scenario. A company has a growing SaaS footprint. Employees are using approved collaboration apps, unapproved file sharing services, and personal AI tools. Sensitive customer records are sometimes copied into cloud apps outside the approved data boundary. Leadership wants better visibility, but the business does not want to block every new tool immediately. A vocabulary-only study approach would ask, what does CASB stand for? A SecurityX decision card asks more, what is the enterprise decision? The organization needs to manage shadow IT and cloud data exposure without breaking the business. What is the architecture boundary? The boundary is no longer only the corporate network. It includes identity, SaaS APIs, browser or proxy paths, data classification, endpoint posture, and cloud app activity. How is it implemented? A CASB might use API integration for sanctioned SaaS visibility, proxy mode for access enforcement, identity integration for conditional controls, and DLP policy for sensitive data movement. How is it proven? Telemetry should show app discovery, policy violations, risky sharing, unusual downloads, user behavior, and exception handling. Who owns the residual risk? If the business allows a risky tool temporarily, the risk owner should be named, the exception should expire, and compensating controls should be documented. That is how one objective turns into a SecurityX level answer. Original concept check, not from the real exam. You are studying the SecurityX objective area around cloud governance and CASB capabilities. Which study note is most useful for SecurityX preparation? A. CASB means Cloud Access Security Broker. B. CASB is always deployed as a proxy. C. CASB can support shadow IT discovery, SaaS visibility, policy enforcement, and data protection, but the deployment mode and evidence depend on the enterprise decision. D. CASB removes the need for identity governance and data classification. The best answer is C. CASB removes the need for identity governance and data classification. A is true but too shallow. B is too absolute because CASB can use API-based and proxy-based approaches. D is wrong because CASB does not replace identity governance or data classification. C connects the technology to decision, architecture, implementation, and evidence. That is the study habit you want. Here are common mistakes to avoid. Mistake 1, studying only definitions. Definitions are the beginning. SecurityX wants judgment. Mistake 2, studying domains in isolation. GRC, architecture, engineering, and operations are connected. If your notes never cross domains, your notes are too shallow. Mistake 3, ignoring ownership. Senior security decisions always have owners, system owners, data owners, risk owners, control owners, and incident commanders. Mistake 4, treating compliance evidence as paperwork only. Evidence is not just for auditors. It is how you prove controls are implemented and operating. Mistake 5. Using exam dumps. Dumps train memorization and create exam integrity risk. Scenario practice should be original and concept-based. Here's the method. For each SecurityX objective, create a decision card. Write the topic. Define the enterprise decision. Map the architecture boundary. Describe implementation and automation. Identify telemetry, validation, and evidence. Name the residual risk and ownership. If you can do that, you are no longer just memorizing SecurityX terms, you are practicing senior cybersecurity reasoning. And that is the point of CAS-005. In the next video, we will cover how scenario-based SecurityX questions test architecture trade-offs. If you are following the SecurityX path, subscribe to Cert Path Lab and keep building the senior cybersecurity mindset one decision at a time.